Hello everyone, I'm Abhishek Vajpayee, and I'm trying to discuss how AI-driven IoT is transforming healthcare. Together with Rathish Mohan, we have explored how these innovations improves accessibility, personalization, and data integrity in the healthcare space. Today, we'll walk you through the evolution of chatbot architectures, the role of scalable infrastructure, real-world use cases, and future impacts of these technologies. Now I will hand over to Rathish to get started.
Thanks, Abhishek. Just to get started, let's first get a general understanding of how chatbots work. Traditional chatbots can be built on static architectures with predefined responses, or the more modern ones using generative AI and other machine learning driven methods. The aim here is to take input from a user and provide an output. These inputs can be text, voice, image, or user actions such as click of a button sent through some kind of user interface, or any versions of those. This input passes through a processing module that can be as simple as a rule-based engine, or could be a complex module using all sorts of machine learning driven submodules to produce and process those outputs. Backend services are connected to other peripherals such as knowledge bases, integrations to other machine learning services, and other such modules that can then process these intermediate inputs and get the final output ready to be served. In contrast, IoT-based chatbots integrate real-time data from devices, allowing adaptive and context-aware responses. They connect directly with IoT sensors to offer precise, actionable insights. So just like the text or image or other signals in the traditional chatbots, IoT devices has an input layer that can get signals from sensors, smart devices, and IoT gateways. This data then is connected to a cloud and can be readily available to be processed by the next stage. This next stage could be an NLP engine, a voice engine, or a full dialogue manager. So this should give you an idea about how IoT chatbots are different but still follow a similar architecture as traditional chatbots. This shift has redefined patient care, enabling 24/7 assistance and timely intervention. One of the biggest advantages is in the accessibility benefits that IoT chatbots provide. IoT-based systems are available around the clock, breaking barriers like office hours and geographical constraints. For elderly or disabled patients, voice-enabled IoT devices provide effortless access to healthcare. For example, a voice assistant can remind a patient to take their medication or guide them through managing a chronic condition. This empowers patients to take charge of their health, fostering independence and trust in healthcare systems. This entire process can be easily automated to detect events and deliver the appropriate care. Add to this a flavor of personalization, and you get a system that is calibrated to a patient's profile. AI systems use recommendation algorithms such as collaborative filtering and content filtering to deliver tailored suggestions. For instance, wearable devices can analyze your activity levels and recommend adjustment to your exercise routine, diet, or medication. Let's look at some of these personalization methods. Recommendation algorithms often fall into these categories as listed on the screen. The collaborative filtering ones, which learns from a user's behavior, the content-based filtering ones, which tailors suggestion based on the item attributes, or you can have a hybrid models, which are combining both for richer insights. These are also called ensemble methods. For instance, a wearable device tracking your sleep patterns could recommend lifestyle adjustments or signal a physician if irregularities are detected. This real-time personalization ensures care evolves alongside the patient's needs. I will now hand it over to Abhishek to talk about how scalable recommendation systems are built.
Thank you, Rathish. Personalization at scale introduces challenges. As user bases grow, systems must maintain low latency responses and handle vast data sets. This is where scalable recommendation systems shine. For example, Netflix processes billions of recommendations daily. Similar frameworks can be applied in healthcare to analyze patient data, delivering timely interventions even with increasing demands. It is critical for AI and IoT systems. Scalable infrastructure allows systems to handle increased data and user demands without compromising performance. This is achieved through use of cloud platforms like AWS and Google Cloud for flexible resources. Real-time ingestion tools like Apache Kafka and distributed computing tools like Apache Spark for processing massive datasets efficiently. These components ensure healthcare systems can scale seamlessly as demands grow. Now we can talk about some best practices for building scalable infrastructures. To build scalable AI ML infrastructure, organizations must follow these best practices. Use data lakes to store both structured and unstructured data. Leverage hyperparameter optimization to fine-tune models for better accuracy. Automate deployment with CI/CD pipelines for quicker iterations and robust systems. This ensures systems remain reliable, efficient, and future-ready. AI-ML infrastructure doesn't just improve technology, it also empowers teams. They build scalable infrastructures, accelerate time to value for clients. Cloud-native tools enable seamless collaboration between teams working on data and analytics. As the client needs grow, scalable systems adapt without requiring complete overhauls. Now let's look at real-world examples. During the pandemic, AI-driven chatbots managed millions of COVID-19 related queries, reducing strain on healthcare systems. IoT-based glucose monitors now send real-time alerts to doctors and patients, preventing diabetic emergencies. These examples demonstrate how IoT and AI enhance healthcare outcomes while improving operational efficiency. Now I'll hand it over to Rathish to talk about some key takeaways.
Thank you, Abhishek. To summarize, we can say that scalable infrastructure is essential for handling growing demands, as we have seen so far. The best practices like distributed data storage and automated training pipelines ensure system reliability and make the system future-proof. AI and ML infrastructure empowers healthcare just as it is providing to other domains of e-commerce. And this providers help the patients, driving them with better engagement and outcomes. As a conclusion, we will say AI-driven IoT is revolutionizing healthcare by making it more accessible, personalized, and efficient. Voice interfaces and proactive monitoring empowers patients, while scalable system ensures healthcare providers can meet increasing demands. However, challenges like data privacy, seamless integration, and service reliability need attention. By addressing these responsibly, we can harness the full potential of these technologies to create a healthier, more connected future. Thank you for your time.